talking about finding the values of a function. We call that evaluating a function. So there'll be many examples here, so you need to be patient with it, because sometimes you evaluate a function with a number, and sometimes you evaluate a function with a different expression. So let's begin. Okay, the first one here, we have like 4 different functions. The first one is f of x equals x squared. And so they give you values of the x on the left side. Those are what we call the domain elements, and it corresponds to certain values on the y. So if you look on that first set, they give you 4 different values, and then when you square them, that gets mapped over to the other side. So if you notice, when you put in 1 or -1 and you square them, you both get 1. That's why it gets mapped to the same number. So, and look at the next function, f of x equals 1 over x, and they give you certain values. They're going to give you 3. Notice that when they give you those numbers, it's just like the reciprocal of the other one. So put in a number, you take the reciprocal of it, but I want you to notice something. There is a number that they didn't put in the domain here. Sure, they put in 3 values of different values of x, but they did not put the number 0 as an possible input or a possible domain element, because what's 1 divided by 0? You're right if you say it's undefined. So that was not a possibility. So 0 is not in the domain. That's why it's not listed there. And then on the next one, we have another function. It's the square root of x. And when you take the square root of those numbers, you get those outputs. So I think that last one's 4 there, and the square root of 4 is 2. So 4 gives me 2 here. Now look at the last function, g of x equals 3. And notice there is no variable involved in that equation. It's just g of x equals 3. Okay? So when you put those 3 values in, they don't care what happens. It's a function. That's what we call constant. So in this case, it doesn't matter what is the input, whatever domain element you want to put in, the output is 3. So that's why in the range side, 3 is the only possibility. Every element is getting mapped to 3 because the value is 3. So when you put in those 3 numbers, like the square root of 2 or whatever, it still gives me 3 because g of x equals 3. That's different if it said g of x equals 3x. So if it said 3x, then you'd have to put those 3 numbers in for the variable x and triple it and get a different output. But since there is no x on the right side, g of x equals 3, 3 is constant. So that's why it's 3 no matter what it happens. So if you list a bunch of ordered pairs, every one of them will have a y coordinate of 3 on that one, no matter what value of x that you put in. So a function is like a machine. It's like a machine. You put a number in for the x. The function's rule depends on what those are. So those pulleys that are inside there depends on what is being put in. So you put number in, depending on what the function's rule is, it'll give you a certain output. It only accepts numbers from the domain of that function, though. So remember that 1 over x would not accept 0. But it's like any machine. I mean, all machines do not take anything. For example, a soda pop machine. You say, well, I mean, what do you put in soda pop machines? Well, soda pop machines, you put something in, and then it gives you soda pop. But you can't just put anything in. You got to put money in, money that it recognizes. So if you put a pebble or some kind of a plastic chip inside of a soda pop machine and push a button, nothing happens, because it doesn't recognize what you're putting in it. So that's not within that machine's domain. What's the range of a Pepsi machine is the outputs. The outputs that machine gives you. So the range of a Pepsi machine would be like a Pepsi, a Mountain Dew, all the Pepsi products. That's the possible range elements of that machine. But the domain is the money that you are actually putting in that it recognizes. So in this particular case, the output would come out with a soda bottle, and then the input would be money that it recognizes. So for each input, there's exactly one output. So if your Pepsi machine gives you push a button, and then a Pepsi comes out and a Mountain Dew comes out, you might be saying hooray, but it's not a machine now. Then it becomes a non-function because it's giving you two outputs. It becomes back to a relation. So if the Pepsi machine is working properly and gives you one output, then it is indeed a function. So one input gives me one output. That's the basic gist of what a function is. So let's look at an example, and we're given a function f of x equals 3x squared plus 2x. Now this looks kind of like it's a very tame problem, but there's 1, 2, 3, 4, there's 8 answers to this one example. And so what we're going to do is we're going to evaluate. Well, we begin with an easy one. We're going to begin with f of 3. So we're going to put 3 into the function. So it's going to be negative 3 times 3 squared plus 2 times 3. So it tells me the x value here is 3. So you do that, negative 3 times 3 squared plus 2 times 3, and use a calculator if you have to, but the value is negative 21. So if 3 is put into this particular machine, negative 21 comes out. So this actually creates an ordered pair on that function. So if you did the graph would have an ordered pair of 3, negative 21 as one of its ordered pairs. So it's a solution, in other words, on that graph. Now, f of x plus f of 3. Okay, now what do you do here? Well, f of x, we know that to be 3x squared plus 2x because that's the name of the rule itself. The f of 3, we've already established. That's the negative 21. So then you just kind of put those together, negative 3x squared plus 2x, and then the minus 21. So f of x plus f of 3, these are just basically two separate entities. So if you notice, f of x is what is the value of f when x is put in? Well, it's the function itself. And then the f of 3, we done that in part A, and it was a negative 21. So if you look at the final answer, if you look at it, there's 3 terms in the answer. Negative 3x squared plus 2x minus 21. Negative 3x squared plus 2x is the function itself because that's f of x. And the f of 3 is the negative 21, which was found in part A. And then what is 3 times the function f of x? Well, the f of x, again, is negative 3x squared plus 2x. And then you triple the output. So then it just becomes a distributive property. 3 times negative 3x squared is negative 9x squared, and 3 times 2x is 6x. So basically when you have functions, when you put in numbers, chances are you're going to get a number as an answer. If you noticed, when I put in 3, I got negative 21, both are numbers. But when you put in x into the function, or something thereof, that has a expression, you're going to get that out, the answer out. That's why you don't, in part C, you don't get a numerical value, because it's f of x, not f of 3 or f of 2 or something like that. So 3 times f of x is just tripling the function. So when you put a number in this time, if you did 3 times f of 3, what do you think you get? Well, if you remember, f of 3 was negative 21, and 3 times negative 21 is negative 63. So you're tripling the negative 21 if it was 3 times f of 3. Okay, now part D, f of negative x. Now f of negative x is taking the opposite of the input. Notice how the expression on the function changes. It's negative 3 times the input squared plus 2 times the input. Well, in this case, the input's negative x. So it's negative 3 times negative x squared plus 2 times negative x. And that becomes negative 3x squared because negative x times negative x is an x squared. And then 2 times negative x is a minus 2x. And that's part D. Now we're on part E. Now it's negative f of x. Before I put this down, let's see if we can figure it out. The opposite of f of x. So what is that telling me? I want to take the opposite of the function itself. So what you need to do is take the opposite of all the terms. Well, the terms are negative 3x squared plus 2x. So what do you think? Let's look at it. So opposite of f of x is the opposite of a negative 3x squared plus 2x. So it's a plus 3x squared, which is the opposite of what you started with. And then a minus 2x, which is the opposite of what you started with. So what are they trying to do? Well, they're trying to show you guys that if you remember the answer to D, let's go back to D real quick. it was negative 3x squared minus 2x. And let's look at E. 3x squared minus 2x. It's not the same. So negative inside and negative on the outside, D and E does not give you the same thing. D is taking the opposite of the input. And then E is taking the function itself and then taking the opposite of the output. And then f of 3x, you are tripling the input. So f of 3x is going to be negative 3 times 3x squared plus 2 times 3x. Now remember, the input in this case is 3x. So it's going to be 3x quantity squared, which is 9x squared times negative 3, which is negative 27x squared. And then 2 times 3x, of course, is 6x. But notice, you put in an expression 3x. What did you get out? You got an expression out. You didn't get just a numerical value out. Now let's look at G, f of x plus 3. Now you're putting in, this time, the expression x plus 3 as a whole. So x plus 3 is its new input. Look what happens. So f of x plus 3 is negative 3 times the quantity x plus 3 squared plus 2 times the x plus 3. So yeah, in essence, you're replacing the original x with an x plus 3, in which a lot of students have trouble with that process of thinking. You can't think of, well, just you're replacing an x with an x plus 3. I think of it as replacing an input with x plus 3. So if you think of x as the input, and then it's a whole lot easier to get this understanding. So anyway, you do the math. So you do x plus 3 squared, which is x squared plus 6x plus 9. You distribute the 2 and get 2x plus 6. And then the final answer is negative 3x squared minus 16x minus 21 if you complete the mathematics there. And if you notice, it is an expression again. And then finally, h, which is the biggie, f of x plus h minus f of x all over h. Now this is actually called the difference quotient. The difference quotient is this. You'll see it a lot in if you're deciding to take calculus. When you start talking about derivatives, it's kind of like the preliminary stuff. But this is called the difference quotient. So you'll hear this again and again. So what we're going to do on this first one is the f of x plus h. Let's deal with that one. Minus f of x, deal with that, and then divide it by h. So it's a long, drawn-out process. So you take the input of the original function and replace it with x plus h. So f of x plus h is negative 3 times x plus h squared plus 2 times x plus h. Okay? And then minus f of x, which is going to be opposite of negative 3x squared plus 6x. So that last negative 3x squared plus 2x is just the original f of x, all over h. And then here you're going to need to FOIL out the x plus h squared and then distribute the negative 3 through it, distribute the 2 on the 2x plus h, and then take the opposite of those last two terms. And I think the next step they'll do that. A lot of times when people are doing this, the mathematics gets kind of hairy, and so they don't know when they're done. I'll tell you when you know you're done. Well, you know when you're done here when the h on the bottom is factored out, canceled out. You can't cancel it out right now, but in a second you'll be able to cancel it out. That's when you know you're done with these difference quotients. So that's just still trying to simplify it. Now we have the negative 3x squared plus 3x squared on the end. The first term and the last term will cancel out. And then if you factor the h out of the middle three terms, you'll get h times negative 6x minus 3h plus 2 all over h. So I canceled the 3x squares out because that was the first and last term. And in the middle three terms, all three terms have an h in it. So I factor it out and I will cancel them out. And remember, that's when you know you're done. And there it is. So negative 6x minus 3h plus 2, which, by the way, is an expression. So, and the original problem was an expression as well. So, now, at this point in time, this means very, very little to you. You just have to get the answer. But I will tell you, this is going to mean, this h right here is going to mean a lot more to you as we progress through mathematics into calculus and stuff. So, but right now, we're done with this. All right, so now we're going to find the values of a function on a calculator. Now this one you can use a graphing calculator, but since graphing calculators are not really used on test, You can also use just a regular calculator and just plug in on the first one 1.234 and then square that number. And then on the middle one, hit 1 divided by 1.234. And then the last one, the square root of 1.234. And they use the graphing calculator, like I said, but you can use a regular one too. So if you square 1.234, it is 1.522756. Now, when you're doing your homework in MyMathLab, it might ask you to round your answer to 2 decimal places. And if that's the case, it's going to be 1.52. So, and then 1 over x is 0.8103727715. So, and if it's on one of my exams, I will tell you what to round it to if I need to. So if I say round it to 4 decimal places, it would be 0.8104. So because the 7's 5 or more, that's that 5th decimal place. And so forth. And so that's how we do those. And so these are pretty easy, and it's just a matter of just punching numbers into a calculator. All right. Now the implicit form of a function. So forms can be written implicitly and explicitly. Fancy names. They're fancy names. Explicit versus implicit. Explicit just basically means solve for y. Implicit means no particular variable is solved. It's just a simple equation with both variables on the same side of the equation. So if you look at this one, 3x plus y equals 5, that's implicit because they're both on the same side of the equation. If you solve that equation for y, you'll subtract 3x to the other side, and it's an explicit form. You know, what's the advantage of explicit form? It's when you're evaluating. So if you're evaluating a function, it's easier to evaluate a function if y is already solved for you. So now if you put in, let's say, 2 into that, it's going to be negative 3 times 2, which is negative 6, plus 5, which is negative 1. But if you put negative 2 on the other side, on the left side, you have to say 3 times negative 2, and then you'd have to manually move that number to the right side. So that's the problem with this. And so that's why explicit form is usually more what you would want. So the middle one, x squared minus y equals 6. If you isolate the y would be x squared minus 6. Now what I would do there is I'd move the y to the right side and subtract 6 to keep the y positive. So if you subtract 6 to the left and add y to the right, and then flip-flop it, you get y equals x squared minus 6. And that last one, how did you get y equals f of x equals 4 over x? How do you solve for y there? You would need to divide by x, because that's the inverse operation of multiplication, is divided by. So y is 4 divided by x. Okay, now let's look at the summary. All right, summary. The important facts about functions, okay? For each x in the domain of f of x, there is exactly one image f of x in the range. However, an element in the range can result from more than one x in the domain. What that basically means, that last part is, a range element can appear more than once for different values of x. But each x can only give me one value of y. Each x corresponds to one y. But a y could have multiple inputs to get that number. So for example, a 5 can give me a 2 and 7 can give me a 2. So that's okay. But a 2 can't give me a 5 and 2 give me a 7. That's where the problem occurs. All right, second one, if f is the symbol that we use to denote function, it is symbolic of the equation that we use to get from an x in the domain of f of x to the range. So that's just a symbolic form, f of x. But they use f of x quite often because the word function begins with the letter f. But you can have a function g of x, h of x, p of x, r of x. So, but typically we use f of x as a default. So, and then the last one here, y equals f of x. Then x is called the independent variable or the argument of f, and y is called the dependent variable or the value of f at x. So now the reason the x is the independent variable because you're independent to use what you want. and it's also called the argument. And I wouldn't spend too much time worrying about those two words so much. You just need to know how to evaluate them and do things like that. I'll let your next teacher worry about that when you start talking more about that sort of thing. But yeah, it's independent, an argument of a function, and what you get as outputs is dependent variable because it depends on what you put in. So, all right. So that concludes this video, and if you have any questions, please let me know. Give me an email, and have a good day.